Hmm. Can I turn on captions? That would be nice. Why? Can you guys hear me? Here, let's start here. All right, so we're in the home stretch. All right, so with my 9 o'clock class this morning, I went on and made a final exam study guide on the spot. Right, basically what it is 10 random questions from each section. From chapter one, we focused on sections 1-1 to 1-6. Chapter two was sections 2-1 to 2-3. Then we did 3-1 and 6-4. Right, so that's what the final exam focuses on. So we have 3 sessions remaining. We have today. After today, we're off for the rest of the week. After the break, we come back. We have two sessions next week. Next Wednesday is our last official day of class, right? So this is a great time to get caught up with your assignments on Pearson. Again, I did make a final exam study guide that you can access on Pearson. We're going to pull it up in just a moment and work on some of it together as much as we can. I'm gonna host your final exam, right? There is a departmental final, but I was approved to like just host your final. So what that means is you can anticipate the final exam to be similar to exams 1, 2, and 3, right? Unlimited attempts. It'll become available Sunday, November, I think that's the 3rd at 11:11 a.m. and is due the following Friday. You have that first full week of December. I think it's that Friday, December 8th at 11:59 p.m. Right? So you have a little over 5 full days to work on the final. Idealistically, when you submit your final exam, in an ideal world, you want that to be the last thing that you submit. So this week is a great week to get caught up on any late assignments or any assignments you wanted to improve your scores on. Um, um, if you are going back and submitting old assignments to improve your overall score, I would encourage you to prioritize your old exams. That's where you're going to get the most bang for your buck, right? You can see the greatest shift in your grades. I'll probably update grades over the holiday sometime. So sometime before we get back, the grades should be updated. And then once you get your exams in order, then you can work. I would encourage you to work on your quizzes and save your homework for last, because the homework is going to be a whole bunch of work for minimal points. Also, I think this group or this course has a lab component, so be sure that you're collaborating with Dr. Lamar to make sure that that's in order. As usual, if you have questions, feel free to unmute yourself to get my attention, and let's get the party started. Let me check on you guys in Zoom one more time. I see there's something in the chat. Okay. Cool. Okay. So what we're gonna do, we're gonna hop over to Pearson, and this is a study guide I made. It's 11 sections, 10 questions a section, right? So it's not for a grade or anything. It's just for practice. So we're going to go ahead and start with question 42. Question 42 is here. Okay. So now as you make your way through the study guide, it has the question ID. This comes from section 1.5, question 9. All right. This asks us to describe how the graph of the following function can be obtained from one of the basic graphs, right? So the basic graph in this case looks like it's the reciprocal function, 1 over x, and we multiply the outside by a number larger than 1, all right? So outside, remember, with transformations of graph, there are a total of 10 transformations altogether. We have two rigid vertical, 2 rigid horizontal. So you can move it up and down or side to side. That's 4. We can flip a graph vertically or horizontally. So that brings us to a total of 6. We can stretch it vertically or compress it vertically. We can stretch it horizontally or compress it horizontally. So that brings us to 10. I think those are all the transformations, right? That's a brief overview, and then you have to go back and, kind of review some of the details. So in order to get this h, start with the graph of the reciprocal function, which is this one. Stretch it vertically by a factor of 6. I just need to leave a message. Stretch it vertically by multiplying each y value by 6. Okay. So if you're not comfortable with that, it's a good idea to review transformations. Again, this comes from section 1.5, question 9. So that's the section you can jump to. Okay. Let's go ahead and generate another one. Let's go to question 106. Okay, this comes from section 6.4, question 51. Use any method to solve the following system. So now when we introduced this, I think we first introduced it with looking at the graph and seeing where they intersect. We also talked about substitution method and elimination method. So, that's a good bullet point to review. I'm just going to use Desmos just because we can. If I can get it to work. Let me see. So we're going to hop over to Desmos. I'm just going to pull this right here. And I'm going to click on Graphing Calculator. And I'm just going to use this, just in the interest of time. 3x plus 7y equals 9, okay? And then 2x minus 7y, 2x minus 7y equals 6, okay? So easy peasy, right? We can look at the graphs, we see that they cross at a point, and we can confirm that they cross at 3, 0. So our claim is that when x is 3 and y is 0, it makes both equations true. 3 times 3 is 9, 2 times 3 is 6, right? So 3, 0 makes both equations true. Okay. All right, let's do another general random number. I'm going to go ahead and mark these guys, so I'll give this some time. Use any, what question did we say? 46. Let's go to question 46. So graph h of x equal to this using techniques of shifting, compressing, stretching, and reflecting, right? Okay. So we're using transformations of graphs. It looks like the base graph is the absolute value of x. Let me think. Okay. Let me zoom out some. I always kind of get this a little bit mixed up, and so I end up having to do a little bit of guessing and checking, which is fine. You try something and then you ask yourself, well, does this make sense? Right? For instance, we want to try to follow the vertex, right? So normally the vertex starts at the origin. We subtracted 10 on the inside. Let me think. I feel like we need to do the flip before we do the translation. So if we multiply x by a negative, that's going to flip it what, horizontally. So we could even, what we could do here is factor out a negative from both terms. And so we'll get the absolute value of -1 times the absolute value of x plus 10, right? Absolute value of -1 is just 1. So that kind of goes away. So then this is really just a graph of the, ow, ow, get down. No, this is really just a graph. Who you barking at? I know you're not barking at me like that. This is the graph of absolute value of x plus 10, right? So if it's the absolute value of x plus 10, then it's just an absolute value that's moved what to the left 10 spaces. Hey, no, no. Okay, let's just try that. So we'll do absolute value that we move left 10 spaces. Now we're saying that the vertex is -10 comma 0. Yeah, that works, right? So absolute value, click to enlarge the graph. Absolute value is here. We said -10, 0, so I think that's here. Okay. And then let me see, when x is, let's do when x is -9. Where y is negative, no, y is 1, right? So -9, 1 is here. Okay. I think that looks good. So all I did was just take the absolute value, move the left 10 spaces. All right, let's see. That should work. Again, we tested the vertex. That looked like it worked, so I think we're okay. Okay. Generate. Let's go to question 5. Okay. Okay, this is straightforward. Graphing a line, right? We have our y-intercept and our slope. Hey, come here, come here. Go lay down. Go lay down. Lay down. Lay down. Just lay down somewhere. Thank you. Lay down. No. You cruising for a bruising. Just be quiet. Don't go. You bright. And get a chill. Okay. So we're here, right? The y-intercept is 2. Just here. Nope. Okay. I just clicked on 2 random points. So what I'm gonna do is drag it to the right. So we said 0, 2. And then if we use the slope, which is up 2 and over 2, I mean up 2 and over 1, that's gonna put us at the point 1 comma 4. So I'm gonna drag this guy to 1 comma 4 right there. Okay, this should be the graph of the line. I'm gonna hit save and check. Okay. Generate question 7. Question 7. Let me check on you guys. I think you're okay. Okay. All right. So find the x and y intercepts of the graph. Okay. I'm just going to use Desmos because. Okay. X squared plus y squared equals 81. X squared plus y squared equals 81. Okay. So the x intercepts plus or minus 9. Okay. Let's see. Can I do this plus or minus? No. What if I do plus minus? No. Plus minus? That's too long. What if I do minus plus? No? Okay. It's not working. I'll just go like this. Plus or minus 9 for the x-intercepts. Okay. And then the y-intercepts, I think, are also plus or minus 9. Okay. Let's go to question 72. Explain why the given function is not a polynomial. Basically, it's because of the presence of the absolute value. All right, it's because of the presence of the absolute value. The function is because of the presence of the negative constant? No. No, is D, right? The function is not a polynomial function because of the presence of an absolute value. Yeah, we're going to go with D. Okay. Generate. Question 11. Right here. Now, this comes from section 1.2, question 3. It says, find the slope of the line passing through the pair of points or state that the slope is undefined. Then indicate whether the line through the points rises or falls as horizontal. Notice they have the same y value, right? So if we go over 5 and down 5 and over, so they're on the same horizontal line, right? Over 1 and down 5, the slope is 0. So for the slope, we say y2, the slope is the rise over the run, which is the change in y over change in x. So the change in y is 0, and the change in x is like what, -4. So 0 divided by -4 is 0. So the slope is 0. So then it's a flat horizontal line. Okay. Generate. Let's go to question 55. Here it is. Okay. So given this f and this g, evaluate f of g of 0. Okay. So this is called composition of function. This means the second function inside the first function. Since we're actually, I want to try Desmos. I want to see if I can do it here, right? So if we say what? We're going to say f of x, oh, there it is. F of x equals 2x plus 5, okay? And then g of x equals 3x squared minus 1, okay? So then let's see if we can do f of g of 0. 3. It spits out the answer right there. I didn't know it could do that, right? That's why I was testing it. So let's just put 3, right? If we did g of 0, 3 times 0 is 0, minus 1 is -1. So g of 0 is -1. Then we take -1 and plug it into f. 2 times -1 is -2, plus 5 is indeed 3. All right, and you see how quickly we did it in Desmos. Okay, so take your pick, generate. 83. Right here. This comes from section 2.3, question 5. It says, use synthetic division to find the quotient and the remainder. Let's see if Desmos can do this one as well, right? Just playing around. Delete, no, no. Okay, that'll work. Okay. Let's just see if we can do it here, right? X to the power of 6, let's just push the limits. 4x to the power of 4, plus 4x to the power of 4 minus x to the power of 3 plus 3. Okay. Let's say, let's call this y. Okay. And then x plus 2, let's call this g. Can we call this like y sub 1? No, that's not working either. F of x. Let's see. If we call that f of x, can I delete this? You're not going to let me call that f of x. X plus 2 g of x. Let me see. What if I said f divided by g? No? Okay. It's not working debate. Oh, that looks good. Oh, No, no, that's not right either. Okay. It might be able to do it. I'm just not seeing it or something I'm missing here. Just want to get rid of all of this. Oh no. All right. So synthetic division, right? Let me just write it out. Oh, I was really trying to avoid writing it. That's why I was hesitating. Okay. So hang on. Come on. Oh no. My device is kind of throwing a tantrum a bit. Okay. Uh, okay. So let's start by getting a copy of this guy. Okay. So synthetic division, right? So when we do synthetic division, the zero of the denominator goes in the chair. So if we're dividing by x plus 2, then -2 needs to go in the chair. We're starting with the power of 6. Come here. Lay down. Lay down. Lay down. Lay down. We need to make sure that every coefficient is accounted for. So it looks like we're going to need some placeholders. So the first one is a 1. Notice power 5 has been skipped, so we need a 0. Go lay down. Lay down. Because you keep barking, so you're totally distracted. Power of 4 is a 4. Go lay down. I'm not saying that for you to just walk out of the site for 2 seconds. Go lay down. She come back, I'm gonna pop her. She's so funny. -3. And then notice it's missing the power of 2 and the power of 1. So we need placeholders for those guys, right? So we started with the degree 6, right? So we're gonna need a total of 7 coefficients. 1, 2, 3, 4, 5, 6, 7. Lay down. Lay down. All right. So then the first, when we're doing synthetic division, the first one just comes down. All right. And then on the diagonal, we multiply. You can lay down. You don't have to go over there. I just need you to be quiet. Just lay down somewhere. Thank you. She goes away for 2 seconds. She's like, is that long enough? She don't understand. On the diagonal, we multiply, right? So we get this. Vertically, we add. Then we multiply. We add. We multiply. We add. If that were 40, so it's positive 38. If that were 40, then it's 80 minus 4 is 76, so a -76. 80 is 160 minus 8, 152. Go lay down. I gotta tell you again. Go lay down. Shouldn't have to repeat myself. All right, so then we add these together. What is this? 159. Okay. So we started with a degree 6. At this point, we're at a degree 5. Plus cubed squared x and this. Okay. All right. Can we just take this one? No, it's trying to create another one. done this one. Okay. So we got x to the power of 5 minus 2x to the power of 4 plus 8x to the power of 3 minus 19x to the power of 2 plus 38x minus 76. Okay. Let me see, where do we make our mistake? X to the 5, 2x to the 4, 8x to the 3, 19x squared, 38x minus 76. Okay, let me check my numbers. 1, 4, oh, there it is. I put a -3 where that should be a -1. Okay. So let me make that correction. All right, so it should have been 1, 0, 4. It's supposed to be a -1. And let me do that in purple so you know that's what I'm changing. And then 0, 0, 3. Let me check one more time. Yeah, 0, 0, 3. Okay, let's try this again. All right. So we had our -2 in the chair. The first one just comes down. It's like she won't go. It's like she doesn't listen until I get aggressive with it. Like I get scary, right? And but it's like if she would just listen the first time, I wouldn't have to do that. And she's like, it don't register until I scare her. Then she like listens. I'm like, yo, why not just listen while I'm being gentle? Don't keep pushing my buttons until I scare you. And now, oh, I'm afraid, like just listen. Like, don't make me go there. Right. I don't know. And it's like, I'm thinking like, what if I had children? It's not, obviously it's not the same because children you can kind of communicate, but I don't even want to have to go there with her. Like I shouldn't have to, you know? And I noticed like even when we're out, if I tell her to come, like if I have to start repeating myself, that means she still don't get it, right? Because all it takes is for her to ignore me one time while we're out, then she's getting hit by a car or getting attacked by some other animal like a bird or a coyote. She's had like coyotes chasing her before, and so it's like when I'm giving her commands, she needs to listen. It's for her own protection. Like otherwise, she ignores me at the wrong time, especially when we're out. That's gonna be it for her. Then we're all gonna be like suffering because she just wants to ignore me and think that what I'm saying, like what I'm saying doesn't matter. And then by the time she realizes it, I'm like, come on, I'm trying to spare you. You need to listen. Um, all right, so let's put a 4. That's 8, -16. I think that's a -17 because we're adding. 34, positive 34, 34, 68, -68. 120 plus 16, 136. So then that looks like that's a 139. Okay, I'm just assuming these numbers are good. It's got me distracted. Um, let me. I should put the degrees and things like that, but what I'm going to do right here. Okay, so that one looks good. Minus 2x to the 4 plus 8x to the third. Now that should be minus a 17 x squared 34x minus 68. Okay, let's try this one. Okay, and then our remainder was 139. Okay, all right, I'm trying to minimize our distractions as best we can. Let's go to question 95. Now it's like I've been spending half the day trying to get her to not be afraid. Like, you just need to listen. If I give you a command, don't keep pushing my buttons. Write an equation of this form from the given graph. We need to zoom out so we can see it. Okay. Can we zoom in some? A little bit more? One more time. Okay, that's decent. Okay, so we're going to take some notes on this one. All right, we're just going to drop this right here. Let's go full screen. That's all the way over there. So I'll just do what I've been doing. All right. So, okay, so they want us to put it in the form of f of x equals a to the x plus b, right? And we want the following points to, we want it to pass through the following points. Now we got 0, 3, that's a huge help. And then it looks like a 1, 4.8, okay? So when x is 0, the corresponding y is 3, right? So let's plug that in. We're going to have a to the 0 plus b equals 3. So then this just means that b equals 3, right? So then now when x is 1, we get 4.8. So we're going to have a to the power of 1 plus 3 equals 4.8. So then a equals 1.8, all right? So then it looks like our f of x is going to be 1.8 to the power of x plus 3. Okay, let's go with this. 1.8x to the power of 3. I totally said the wrong thing. It's 1.8 to the power of x plus 3. I know, I think I said 1.8x to the power of 3. That's totally, I said the wrong thing, but I wrote the right thing, I think. Let's see. Integers or decimals. Mm-hmm. If we subtract, we get 1.8. Is that 4.8? Mm-hmm. When x is 0, we're at 3. When x is 1, we should be at 4.8. Oh, f of x equation. No, we got that. Can we? Yeah, 0, 3. Maybe don't use the parentheses, but that shouldn't make a difference. I don't know. Let me see. Substitute. I don't know why this isn't working. Use integers or decimals for any number in the expression. One point eight to the power of x plus 3. When x is 0, we get, I did the 0 wrong, right? I totally did the 0 wrong. I'm glad I kept checking. Right? The 0. A to the power of 0 isn't 0. A to the power of 0 is 1, right? That's where we made a mistake. So a to the power of 0 is a 1. So then that means that this is actually a 2. All right, that's where we're making our mistake. So this is actually 2, right? Okay. So that means this is 2. Subtract 2 and we get 2.8. All right. 2.8. Okay, let's try that. 2.8 and plus 2. Okay. So 2.8 to the power of x plus 2. 2.8 to the power of x plus 2. And yeah, we caught it at the nick of time. We got a solid 10 minutes. Let's take advantage of the 10 minutes, right? Oh, and then when x is 3, Siri, what's 2.8 to the power of 3 plus 2?
2.8 cubed plus 2 is approximately 23.9519.
9519? 2 decimal places, so just 95. Okay. All right. Let's try another one. Generate 54. Let's go to 54. I feel like I need to zoom out some. Before I start this one, let me check on you guys in Zoom. Dwindling fast. So the functions f and g are given. Find each of the following and state its domain. So f plus g, so then it's just going to be x plus 5 on top. Okay. Okay. So f and g are limited, right? For rational functions, the domain is going to be all reals except any x that makes the denominator 0. In both cases, we have to throw out x equal to -4 because it makes the denominator 0. Let me zoom out some. So we have to throw out x equals -4. Okay, so everything except -4 should be D. F minus, so if we say f minus g is going to be 5 minus x on top over x plus 4. Okay. I think it's the same limitation, right? We can't divide by 0, so we have to throw out -4. F times g, so 5x over x plus 4 squared. Same deal, we can't divide by the 0, so we got to throw out -4. And then if we say f divided by g, so when we say one fraction divided by another, we do keep, change, flip. So the x plus 4s are going to cancel. So now we have 5 over x. So now in this case, we still have to throw out -4 because the originals can't be equal to -4. But because of that final form, it's saying that we also need to throw out 0. So we got to throw out -4 and 0. So then that should be A. Okay. G divided by F. So we do keep, change, flip. I think this is going to be the same thing, right? No, G divided by it's going to be x over 5. So it should be the reciprocal. That was going to be x over 5. So again, because the original we had to throw out -4, we still need to throw out -4. But since we're dividing by 5, we don't need that added restriction of 0. So it should just be A. Okay. Let's do at least one more. Generate 35. Determine algebraically whether the given function is even, odd, or neither. The definition of a function being even, odd, or neither, for even, whenever we evaluate f of -x, we get back to the original. For odd, whenever we evaluate f of -x, we get a negative times the original. So if we replace x with -x and you simplify, you notice that you're going to get back to the original, which is the definition of a function being even. Let's do another one. All right. Find the center and the radius of the circle. I'm just going to look at the graph. All right. So now we got x squared plus y squared minus 8x plus 2y plus 13. Let's see what happens if we set it equal to 0. Now it looks like, according to this, it looks like the center, what is that? 4, -1. So what we should really do is group our x terms together, group our y terms together, and then factor using completing the square. The radius looks like it's what, 2? I feel like I should write this one out. I'm just gonna eyeball it just because we're kind of short on time. So we said what, 4, -1. But I know we don't always have that as a luxury, and the radius is 2. Okay. I kind of want to do another one, but that's enough. All right, gentlemen. Are there any burning questions? You might have to type it in the chat if you have any questions. Are there any burning questions? Okay, I'll check the chat in just a moment. Let me say again, as far as closing announcements. So again, we're off for the rest of the week, right? So happy holidays, enjoy your holidays. Spend time with loved ones, eating some good food, laughing, playing, and be sure to tell someone that you care about them. Let them know that you do care about them, that you're grateful for, having experienced their energy. And if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, happy holidays, and we'll be back next week, same time, same place for the final week. All right, guys. Happy holidays. Take care. Peace.
Hey, Mr. Favre, I was wondering if we could discuss my grade privately, briefly.
Okay. And then so